Okay, in example 8, we're going to be comparing 3 polynomials that are in factored form. They have some similarities and some differences, and then eventually we're going to be trying to match them up with these 3 graphs. Now, obviously, you could just plug these into your calculator and see which graphs they match up with, but we want to use these as an opportunity to kind of talk through very similar polynomials, but the differences that we see, especially when it comes to their x-intercepts and the multiplicities and how those kind of have an impact. So remember, coming into this, what we've talked about so far as far as multiplicities. Multiplicity means multiple copies of a factor, like what we see here with x plus 2 squared. That's 2 copies of that particular factor. And then it also impacts different types, odd versus even multiplicities. Odd multiplicity was when we had the graph crossing, and even multiplicity was when we saw the graph bouncing. So odd was crossing, evens bouncing. All right, if I look at all 3 of these polynomials, they all share basically the same factors, x plus 2 and x minus 3 in different combinations of multiplicities, which means they're all going to have the same x-intercepts, aka zeros. X plus 2 is going to correspond to the x-intercept at -2, and x minus 3 is going to correspond to the x-intercept at 3. And all 3 are going to have the same x-intercepts. You can even look ahead to the graphs and see, yup, every single one of these graphs has an x-intercept at -2. They act differently, but they all have that -2 x-intercept, and also at 3. So that's something that these graphs all have in common. All right, let's talk about multiplicities. Here I see a multiplicity of 2 because I've got 2 copies here. Here I see a multiplicity of 2 for x plus 2. Here I see a multiplicity of 1. Here for x minus 3, I see a multiplicity of 1. Remember, just how many copies of that factor. That's what we're talking about with multiplicities. Multiplicity of 1. And then for x minus 3, a multiplicity of 2. All right, a multiplicity of 2, that's even. That means my graph should bounce. Multiplicity of 1 is odd. That means my graph should cross at that x-intercept. So 2 even, which means it's bouncing. 1 odd, which means it's crossing. Okay, those 2 tables look identical. How will we be able to tell these graphs apart? Well, one of these graphs will have a positive leading coefficient, and notice this graph will have a negative. So that's going to be a key difference between these 2. All right, back to our multiplicities. Multiplicity here of 1, that's an odd multiplicity. That means the graph will cross. 2 is an even multiplicity. That means the graph will bounce. All right, so this one's unique. Let's do this one first. We need it to cross at -2 and bounce at 3. Cross at -2, bounce at 3. Which graph does that match with? That's going to be letter A here. It crosses at -2, bounces at 3. So I'm going to say this is graph A. So that one has been eliminated. All right, between B and C, these 2 we knew were going to be similar. They were supposed to bounce at -2 and cross at 3. It does bounce at -2, crosses at 3, bounces at -2, crosses at 3. So we're on track there so far. We said that the main difference between these, or really one of the only differences, was going to be about the leading coefficient and what impact that had. Remember, the leading coefficient impacts end behavior. So a positive end behavior, this is an odd degree overall. If I multiplied this all the way through, I'd get an x cubed polynomial. Positive odd end behavior was down and up. You can check back in your table if you don't believe me. Whereas negative end behavior for an odd, again, x to the 3rd overall polynomial, was up and down, so flipped around. So that means this corresponds to letter C, because this is up and down, whereas this would be the positive one, down and then up, because it would connect like that. So this one is graph B. This one is graph C. So it should go B, C, A.